Hello fellow modelers, this tutorial will focus on how to model an actual screw and its nut to precise scale in Blender. The first thing we want to do is setting the scene correctly. So we go to scene properties and we make sure that millimeters are selected. Now in my case this is already done. I saved my own custom startup file so I don't have to do that every time, but in any case this is the setting. Since we want to be precise here, we need to have some data. This is the chart that I use the most. Now, depending on where you are on the planet, you may need to find something different from ISO, which is the standard that I'm using where I live in Italy. The core principles will still apply, no matter what you're after. Only the numbers will change. So, for the sake of this tutorial, we will be modeling an M6 size Allen screw, code 5931, and then the corresponding nut, which is code 5588. So there's a whole lot of numbers here, but we just really need a few of these. More specifically, we need to know the pitch, which basically is the distance between each thread, then the major diameter, also called nominal diameter, and lastly the minor diameter. And we actually see we have two minor diameters for each measure, one for the screw and the other for the lead screw. So let's just get rid of everything and add a circle and set our major diameter, which is 6 millimeters. Blender just asked for the radius, so we plugged 3 millimeters. Tab into edit mode, select everything, deselect the vertex on the y-axis, Ctrl-I to invert selection and delete the other vertices. We add another circle, this time with the minor diameter divided by 2. Same treatment as before, and we join the two remaining vertices. Move the minor 0.5 millimeters on the x-axis. Select both vertices, Shift D to duplicate, Escape to release, SX-1 to invert, and M to merge by distance. And yeah, now we can apply our screw modifier. Set the axis on X, the steps to 18, and since a screw turns clockwise, the screw must be negative, so set the screw to -1 millimeters. I usually put a number of iterations which is twice the diameter. Back to object mode, now it's a good idea to duplicate and hide the screw, just to have a backup, because now we apply the modifier, and once we do, it's permanent. Back into edit mode, A to select all, M to merge by distance. Now select the last edge loop, deselect the thread edges and the very next one, E to extrude, X to constrain the axis. Press SX0 to even out the edges, then with the move tool position the loop close to the thread. Now if you add a loop cut along this new created geometry, you see that you can fill the missing faces with quads. The same thing applies to the other side of the screw. And if you experience any clipping in the viewport as I do here, just go to the view menu and lower the clip start value. Now that we have perfect circles at both ends of our screw, we can do our ordinary extrude and scale pattern. This is the tip, we just add a support loop and then fill the end with grit fill. On the opposite side, we extrude the loop on the x-axis, then extrude and scale to start the head part. We set our cursor on the medium point with Shift S cursor to selected, so that now we can add a new circle with the appropriate radius in its dialog box and rotate it of 90 degrees on the y-axis. Reach the edge loops, then extrude on x-axis again to set the height of the head. Now, to make the head socket, we need to solve a little math problem. Sockets are usually referred to with the gauge of the tool used to operate them. In our case, a 5mm Allen key. So we need to figure out how to model an hexagon out of only knowing the distance between two parallel edges. Now, in Blender, we usually do polygons by adding a circle and setting number of vertices along with the number of sides that we want in our polygon. So in our case 6 vertices, and this is a radius of 2.5. Now the problem with this, if we plug the radius of 5 millimeters of diameter, which is 2.5, we are getting an height which is not 5 millimeters, because 5 millimeters is this distance here. So we need to get this distance to be 5 This happens because the way the circle function works, it places each point at a radial distance, so basically each time we use the circle function we're actually inscribing a polygon. So geometrically we need to scale our hexagon so that the edges and not the vertices are touching the circumference. If we split our hexagon into 6 equilateral triangles, we find that what we are searching for is just the height of each one of them. This height is called apotheme. So the circumscribed circumference is equal to 2 times pi multiplied by apotheme divided by the cosine of 180 degrees divided by n, which is the number of the sides of the polygon. In our case, n is equal to 6, so we have the cosine of 30 degrees, which is the root of 3 divided by 2. We also know that the circumference is equal to 2 times pi times the radius, so we plug our findings in the formula, we simplify, and finally we obtain that r is equal to 2 times apotheme divided by the root of 3. Now, if we substitute a with 2.5, we obtain our solution, which is about 2.8867. And if we add a circle and put that as a radius, we solve the problem. Alright, so let's go back to our screw, add a new circle, set 6 vertices, plug the new value we just found for the radius and rotate it 90 degrees on the y-axis. Now let's shift R on each edge to create a vertex in the middle. You can probably subdivide it and have the same result, but this is how I do it because apparently I made out of time. Then, with all the middle vertices selected, press Ctrl-Shift-B to bevel them in an even manner. Now select the whole hexagon, then press ES to create another support loop, then ES again to add a further one, which will be right-clicked, loop-tooled, and circled. Now bridge the edge loops and the edge is almost done. We just need to have some support loops here and there, taking advantage of Ctrl-B to bevel them out evenly. And in case you followed my previous videos and have diligently subscribed to my channel, you probably already know that I'm a big fan of the bevel modifier. I always start with a low amount like 0.5 or so, set the width type to width and the limit angle to weight. This means that Blender will only bevel the edges you'll designate. You just have to select them, go to the Item tab on the right side and slide Min Bevel Weight to 1. If things get messy, select All with A and Shift-10 to recalculate normals. And if you have short memory issues like I do, it's probably a good idea to have frequent looks at the model, because there could be areas that you have completely forgotten, like the socket here, for example. Let's also not forget to add a subdivision modifier and set it at least to 2. Anyway, short memory apart, you should now have something that looks like this. If you want more sharpness on the thread, and rightfully so, just lower the bevel amount to maybe 0.1. Now the nut has almost the same workflow with only slight variation. In object mode, add a new circle and set the radius at nominal value. Maybe isolate it with numpad/ to see it better. Select top vertex and Ctrl-I to invert selection and delete. Then add another circle, but this time plug the radius of the lead screw we found on our reference, which will be slightly bigger than the one we used for the screw. Once again, isolate and delete, then join. Move the lower by 0.5 on the x-axis. Duplicate, then SX-1 and merge by distance. Add the screw modifier, select x-axis, set the screw to -1 and the number of 4 or 5 iterations. Now if you turn the screw back on, you see that it's matching perfectly. And before applying the modifier, don't forget to set the viewport steps to 18. Once applied, go to edit mode, select everything and merge by distance. This is where it gets a little different from the screw we just did. Nuts always start with the major diameter, so we have to remove some faces from each side before we even out the edges. You probably noticed that the loops at each side are much closer than before. That's because we want our nut to be around 5 mm thick, as mentioned on our reference. You can use the grid on the background as a guide. The remaining part is basically repeating what we did with the screw head socket. We set our cursor at the medium point at one of the sides, then we create an hexagon. If you're lucky, you could find the diameter you need on the reference. Otherwise, just apply the formula we found earlier. Add a vertex on each side of the hexagon, Ctrl-Shift-B to bevel, ES to extruding for support, ES again and loop to a circle, rotate to adjust, bridge edge loops, and boom, you got the face. Select the circle and mark seam, then L on the face part to select it, Shift D to duplicate, and X to constrain the axis and snap to the other side. Select all and merge by distance. Select both hexagon's edges and bridge edge loops again, Ctrl B to bevel supports, and finally apply our favorite modifiers once again. And there you go, you made your first mechanically accurate screw and nut in Blender. I hope you enjoyed the video, and if you did, please hit the like button, leave a comment and maybe subscribe to the channel. Thanks for your kindness. I'll see you on the next one, and before that, take care, stay safe, and happy modeling.